Hello, everyone. Welcome to I think it's the first Wolfram Language Design Review of 2023, if I'm not mistaken. So this is part of our incremental language development series, and we have a variety of topics here. Okay, integer chop.
So we started talking about this really briefly in the previous meeting, but the idea is that chop is a fairly useful function for taking approximate zeros down to zero, but it only works on zero. It's more specific than round, obviously. And Ed had put together a WFR function that does this for arbitrary integers.
Why isn't this floor? Because it doesn't, because it only does it within a certain range.
Yeah, it's only doing it within a certain tolerance.
It's floor with a tolerance, effectively. Well, I don't know. Really.
Is it round with a tolerance, right?
Yeah, but it's none of the above because it's not always making an integer.
Right.
Which is why IntegerChop isn't a very good name for it, because it doesn't always make an integer. That's its whole point. I mean, if it says, yeah, see,
yeah,
it's sort of like a snap, like it's snapping to a grid or something.
But
yes.
rationalize doesn't make rational either.
Sorry?
Rationalize doesn't make rational number either.
Well, I know, but that's a version 1 name that probably wouldn't be. I mean, this is.
It's more or less the same thing.
Well, but now what happens if I have if I have this integer chop thing and I have, whoops. And I have 6.99999. What the hell is that? Is that just a print form?
I think that's a print form, yeah.
So it's a downward chopper. I thought that chop.
It does within a tolerance. I mean, 0.999 is not close enough.
For the test, you might need more nines.
But I don't understand, because chop.
Do like 10 nines.
Maybe it should be integer round.
Well, I think the point is not the chop is the problem. The problem is the integer.
That's a fair point, yeah.
Right. I mean, I assume that the point is that there's a 2-argument form where the second argument will be, 1/2, and then it will chop to the nearest half.
Yeah, I think so. And
well,
then there'll be a tolerance.
I don't know. That's not the worst issue in the sense that it's sort of an extension.
From a linguistic point of view, chop may not really make sense for the 6.9999999 case.
Yeah, I mean, basically what the overall goal of the function is take an approximate integer and turn it into an integer if it's within a certain tolerance.
Right.
Right. It is like snapping to, I mean, it's like, if you use any kind of graphics editor thing, it sort of snaps to a grid. That's exactly what this is.
Yes.
Integerize.
But it's not integer.
Well, again,
I see.
That's, I guess, the primary use, but
I actually like Stephen's name because it's very much like rationalize. I mean, if you can do it within the tolerance, it works. If it can't, it can't.
Well, what Christopher's bringing up is that we can extend it to non-integers, to other rationals, for example.
But we have many functions where its primary name.
Yeah, that's what I'm saying. That's why I also think integerize is perfectly reasonable.
Well, maybe the only other problem with integerize would be, and maybe, well, I'd be a little afraid that people would say, oh, I've got something that isn't an integer. I want to make it an integer. And what they want is round or floor or something like that. And they say, oh, integerize.
Well, rationalize doesn't always return a rational either.
Right. It's totally.
I know that point was made, but it's not clear.
Yeah.
That's a great feature of rationalize.
How about round chop?
It strikes me as incomprehensible.
Sounds like a piece of meat.
It does.
But round does the same, or chopped has this thing where sometimes it evaporates and sometimes it leaves it unchanged. So I
Could-
think that's good to be in the name.
Could rationalize possibly just be given extra cases?
No, I don't think so. I think it's too obscure because this case here, I mean, how does rationalize work? Let's see.
Sorry, I was on mute. It's a continued fraction approach.
No, I know that, but I mean, it is
In the
within
details, it explains. It's in the details.
right. But I mean, also, but the dx here is a tolerance rather than a snap grid.
Yeah.
Well, which is more useful? Maybe the tolerance is the more useful second argument.
I think for rationalize, that's the case. For this integerize, I'm less certain.
I mean, but chop also takes an epsilon, right, as its second argument.
Yes, it does. Which suggests this should as well.
Yeah. And then what if, I mean, it seems, I'm trying to think of when it would be useful to, I mean, if you wanted to snap to the nearest half, or another version would be maybe you give it a list of values to snap to. But I'm not sure how useful those are. I mean, those are the obvious generalizations.
I mean, I think, yeah, it's either, I'm trying to think about whether that list of things, that's a bunch of catchment basins, so to speak, that you're giving it, it's like nearest, essentially, at that point.
Actually, you could, that's true. And in fact, you can even write it with nearest, because nearest has a syntax for, it's a little obscure, for only finding results within some radius.
Right. Well, I think we should consider integerize. I think it's an understandable name, and I think it's, I mean, let me think about this for a second. Yeah, I think it's a reasonable name. Anybody object here? And we're basically doing an x dx type of deal.
Okay, I think that makes sense. We'll review it again and consider the name
Fine.
when we finalize it. But yeah.
Okay.
Right.
Will it work on a round?
It work on a round.
Why not? If it's within the dx, just crush it into an integer. Seems right to me.
Yeah, I guess we do.
Right.
Michael, do you agree?
Intervals,
to chop.
intervals and quantities would be nice.
Maybe tendered
Yes.
intervals, but not intervals.
Why? The whole interval is within dx.
Maybe.
Also, what's the default dx?
Presumably the one for chop.
Yeah, what is it like? Machine.
Is it machine? It's not machine epsilon.
And just to make sure that we're all on the same page, it also works for rationals that are a tiny bit off.
I think so.
And Gaussian integers.
Yes.
Good.
Well, it's 10 to the minus 10. Chop should really have the tolerance option. No, actually, you're saying it has it as its second argument.
Yep, it's just
The way we do documentation now, we should put that second argument up into the main usage.
Yep, I'll move that up.
Okay. Hard body systems.
Yes, so we started talking about this also last time. We have Rob here also because we had talked about potentially either generalizing what we have in n-body simulation to work here also, or doing basically the same thing for hard body simulation.
Right.
And since
the fact is that the more I look into this, the number of people who've used hard sphere gases as a model for things or hard objects is just so freaking large, going
Yes.
back, forever. And
the main use today is actually for jamming, not for dynamics anymore.
Fair point. Okay, so the way you're doing that, go ahead.
Do the jamming problems have multiple incidence issues?
They're static. They're not dynamic.
They're not dynamic at all.
No. And they have yes. Otherwise, they are not stable if they not have multiple points.
Yeah, but I think the thing we're trying to do here, I don't understand why we wouldn't want something which is a combined n-body simulator, and things are gravitationally attracted and then they bounce off type thing. Why wouldn't that be the story?
One thing is, at least in my experience, that it's sort of hard to get simulations like that not to have crazy things right. You get sort of singularities and stuff very, very easily, and you get weird situations.
In what kind of singularity?
Well, I just mean if you have collisions, it's sort of for example, if you have adaptive sampling, the way if you just do it with a when event kind of thing, it's going to be there's standard ways of solving the problem of singularities without collisions, where you just use some Hooke's law thing when they get too close, or you just have a tolerance where it's within this radius, you just don't apply the attractive force or whatever. There's nothing that I found in the past really like that for collisions. Maybe we can make something up and it'll be close enough, but yeah.
Wouldn't we not just kind of like within an epsilon layer, where epsilon, don't know, 10 to minus 6-ish, 8-ish, we have a potential that goes smoothly from 0 to infinity?
Well, that's not what these things, look, these hard sphere simulations are based on algorithms that really are just geometrical algorithms about spheres.
This was for the case where we have both gravitational plus hard sphere.
Yeah, I understand, but that seems like it'll be, look, the fact is, the question is it really, and it may be, essentially a different domain of operation to be dealing with genuine hard spheres as compared to dealing with potentials?
Absolutely, yeah.
Well, which
I think
suggests,
it is.
yeah, okay, fine. So then maybe we should just have separate functions and not pretend we're going to do the two together. That if you want to do something which has some repulsive potential at short distances, then put it in an n-body simulation, and maybe we have a standardized potential that does that.
Yes and no. What we do right now in n-body simulation is space differential equations. The name doesn't suggest this in any form.
Well, what else would we do other than differential equations? We're doing equations of motion. I'm confused.
But the name n-body simulation just suggests there are interactions between n-bodies, and that's exactly the case for the hard sphere gas.
I know, but people usually, by n-body simulation, people have usually evolved to mean this differential equation-based thing.
That's correct.
Yeah. You could, if you really want them together, you could have two separate cases, and we just give a message if somebody tries to mix. But that's essentially having two different interfaces anyway.
But then it will be n-body simulation instead of harmonic, for example, we'd say hard sphere or something like this.
Yeah, right.
Well, I think one reason for having two different functions is because we might want different output forms for the.
That's a good point, because there are discrete events in the case of hard spheres, which there are not. Yeah, it's a good reason to do that.
And, some of my experimental stuff has output forms that we could possibly look at. It's not a list of coordinates and times and stuff. It's an event list.
Yeah, which is something we can get there, which is completely unavailable in the continuum case.
Yeah.
Mm-hmm.
Yeah. And then also, let's say we're adding in gravity. Well, I think that the gravity will be like we have one in-body simulation solution between each event that happens, and the events are actually kind of like singularities because they're involve discontinuous changes.
Yes, but is that realistic to have a? Okay, question. I mean, what are you proposing? Are you proposing some combined function? Or
I mean, let's just look at how the hard sphere algorithm works. These things are going all over the place. They collide, and when they're done colliding, or when they're in between collisions or wall reflections, they're just doing like a Galilean translation.
Yep.
So the thing that changes in the algorithm when adding gravity, which I think this is really interesting to add gravity, because then, you know, we could do hard spheres bouncing in a container or whatever. That'd be pretty cool, I think.
But the problem is you will no longer be able to compute when the next collision happens.
You can maybe compute when the next collision happens using something like n-body simulation.
That's not obvious to me.
So, and right. It's not good enough. It will be off.
You'd have to have an event, and the time step would probably have to be set so small it's not realistic in general.
Correct.
But what about if you can symbolically solve the equations of motion?
So for two bodies.
Yeah. Okay. Fine.
Even Hooke's law you couldn't do for many.
Right. Good point, Mike. Well, you could make an approximation, but
then we got the same problem of it being off.
You might get one step farther with a clever beta ansatz for Hooke's law.
Yeah.
Okay, fine. Well, I mean, it suggests, all right, so basically the conclusion is let's be realistic in what's possible and just say, you know, we are basically, for now, we're just doing hard spheres, and we're doing, you know, we've got the n-body simulation and we've got hard spheres. I do think that, you know, we are beginning to sort of go into a general domain that includes things like agent-based models. I mean, this is the same type of thing where we've got properties of essentially discrete objects that then have, you know, dynamical behavior and so on. And but I mean, it seems like the design of n-body simulation. Okay, how do people feel? I mean, the times I've wanted to use it, the design has been pretty decent. What do other people think?
Yeah.
Okay. And how similar is that design, Brad or others, to the hard sphere simulation design?
Well, one issue that I was thinking of is like if the output of an event chain algorithm is very similar to a causal graph, then the users might want to know where the particular mass is at an intermediary time. So there might be a different algorithm that we would need for interpolating the causal graphs to get that.
But the point is that there are causal graphs are a possible output for a hard sphere simulation in a way that obviously, I mean,
I've been looking at it lately that the causal graph is actually the fundamental output of the algorithm, but it's carrying a little bit of extra information on the nodes or on the edges.
Sounds right to me.
Right. Well, interpolating function does have a mechanism. This was set up for the win event stuff. I mean, I don't know if it'll be useful, but it does have a mechanism for discontinuities and interpolation between, you know, for points in between discontinuities.
Sounds right.
That's I'm not sure that that's the same issue. What I'm really talking about is like, okay, you have this big graph with a bunch of nodes in it, and you don't necessarily, and the nodes kind of have some time stacking. But if you want to find out where the node or where particle 3 was at, you have to look at the events that particle 3 was in, but in the linear order of events with time, you don't necessarily know where the first 3 event is going to be, nor the next 3 event. So it's a little more difficult than just interpolating the type of output that you would get.
Yeah, fine. Yeah, so you need a different data structure.
Yeah, you need some interpolating function that's sensitive to the data structure.
All right, question. Are we only doing hard spheres? Are hard squares a possibility?
Well, the hard square code I'm just thinking of it right now as a pathfinder. Whatever we get to work with the hard square code, we can potentially get to work with the hard sphere code, except that I think the hard sphere code is really nice when it gives us solutions that are entirely over the rationals. Those are the easiest to compute. We never lose precision. But then with what I'm expecting to happen with the hard sphere case is that even if we can get exact numbers for intermediary states, they'll probably become, huge expressions, so that memory will slow down the computations and necessitate numeric approximations.
Okay, but we should allow, say, a couple of thousand digits, because this is totally realistic.
And you certainly can't do that with algebraic numbers, that many collisions that you're talking.
Right. But okay, I'm trying to ask, our hard squares are non-rotating squares, right?
Yeah.
And
no, I think the hard square thing is great.
Yeah, but how seriously, I mean, what are we going to call this function? And are we mostly going to say it's a hard sphere function, but it'll have some opportunity to do hard squares, non-rotating hard squares?
It should be hard sphere based, where anything else is just I don't know, a curious extension, because of the fact that it doesn't support rotating.
You could just claim that they're topological spheres.
I think this is about geometry.
I know, but that would give you freedom for all kinds of shapes in the name.
Yeah, well, I haven't actually asked the question whether it's still possible to get exact solutions if you allow weird shapes and rotations.
I think it's probably quite difficult. But okay, let's just go through this. So what we've got here is some options. So we don't have a radius. There's nothing like radius, is there? There's in n-body simulation. It's just mass. I mean, here we also have a mass, presumably. We have the same things, mass, position, velocity, except these are point particles, right?
Yeah.
Right.
So we probably just want to call it radius, mass, radius, position, velocity, etc. Default radius is 1, right? And we probably want to have, I mean, I don't know what steps means here, but this thing here is a time parameter, and it's the same deal as this would also have a time parameter, presumably.
Yeah.
Does that make sense? An n-body simulation has an output. I think it has multiple output possibilities, right?
Yeah, you look at the data, it gives a data object, which then you can query for stuff you want.
Where does it say what you can query it for?
Well, go to the page for n-body simulation data.
Where the hell's the information? And wait a minute, what the hell's going on here? How do I just get a list of positions? Oh, I see. State of body.
Right.
Well, okay. I mean, this seems about right with a given property here. And then in terms of this combined properties, there will be a causal graph as one of the possible things here. Right? Or instead
maybe, but is the total kinetic energy as a time dependent? I mean, it maybe is invariant, but it's also, is that evaluated per time?
I don't know.
Yeah, you can plot it for the ND solve simulation. It's evaluated as a function of time.
And assuming it's a conservative potential of some kind, it should be constant.
Right.
Okay.
Yeah. So the causal graph is almost
No,
bigger than.
So,
what I
sorry,
think
no, the
total
total
energy-
kinetic energy is not preserved
Right,
because
right.
because there are
it's
interaction in the energies.
the total
Right, but
energy.
the total energy, that's
Yes.
the third one there,
Yeah.
Michael.
Yeah.
It should, I mean, it doesn't always work that way because of ND-solve has errors,
Yeah.
but
Yeah.
you know,
Can you
it's
see the
usually
virial
pretty
theorem?
close.
I mean, each time you should be able to see the virial theorem. Is that true, Michael? Between the kinetic energy and the potential energy.
I think in average, if you have enough, yeah.
Okay. So,
But looking at the causal graph is like looking at the whole data blob, and then asking for a particular state of a particle at some time is like looking at a slice of the data blob.
mhm. Look, I think we've got a basic plan here.
Yeah.
These things about boundary conditions, we obviously don't have that in the case of n-body simulation. Presumably we could have an outer boundary. We haven't wanted that particularly, but I don't think
we
it would
do
be
have
bad.
that for n-body simulation data.
An outer boundary for the,
Yeah, I mean, if I point out there's an example where it's done in a region.
I don't want to see an example. I want to see it in the documentation. Is there a way of specifying a finite size region in n-body simulation?
Yes.
And you don't, but you didn't document it.
That may not have been documented.
That's very bad. Oh, region. Wait a minute.
Yeah, that's right there.
Okay.
I somehow thought it was there, but
All right. Well, fine. No, I mean, this is very lame documentation. I mean, come on. We can do more than 10 examples here. 11 examples for this function with all these pieces. Please, could we add some examples, Rob? Or if
yeah, I'll talk to Roger, see if he can get somebody to add some examples.
well, if Brad is looking at this stuff, maybe he could add some examples.
Yeah, that would be
I probably
wonderful.
could. The virial theorem thing sounds interesting to me.
Yeah.
Well, this is perfectly reasonable what you have here. Where's the
There it is.
a disk? Okay. That's nice. That's nice. That's exactly what we should do here too. Now, I don't know whether there are graphics that are non-trivial in the hard sphere simulation case. Maybe these things with tails and so on might want to be one of the properties. Is something that can readily give you the tailed graphic, so to speak. I mean, I think that's another thing that would be nice here too. Oh no, I guess not, because you can't show tails because there are no. Well, we could show the instantaneous positions of the bodies together with their velocities as tails. Does that make sense?
Yeah, sort of like one of those fish plots or whatever you call them. Yeah.
At least as a WFR, that should be a thing we have. I mean, I would even argue that that's having a type of plot, having something which is a, position velocity plot would not be a terrible thing to have as a standardized plot type. Michael or anybody else, do you want to comment on that?
I don't think plots in general are what people do in this world, but much more correlation function, averages.
Well, I know that's what they do when they're writing research papers, but it's not what they do when they're exploring things. I would like to propose that we consider some kind of plot like this that takes, x, y, I don't know how we do it, dx, dy. I mean, I guess I've wanted this many times. I mean, I've written, it's not very hard to write, but it just seems like the kind of thing we should have some way to do. Maybe it's effectively a velocity plot of, what is that called? List, not stream plot, but the other list vector plot. Is that right?
Yeah, but that kind of plots a vector field, doesn't it? And you just want to plot
Yeah.
few points that are not the whole field. So it's a little bit different.
Yes, it is. Oh no, actually look. At specified points. This is exactly the thing I'm asking for. Well, then we just need an example. In list vector plot, we need an example of embodied simulation. In embodied simulation, we need an example for a list vector plot. And then we have it solved. That makes sense?
Yep. Do you want to do that, Brad? While you're looking at this stuff?
Sure. Yeah, I need to get some training on updating documentation anyways.
Okay. All right. So I think we have a plan here. Are there any other different things that need to be specified other than a radius option, a radius thing here? And we won't have a first argument. It'll just go straight into this list of parameters here. And then we'll have a time, a time that we want to compute it for. We should have the possibility later of adding a string first argument that makes the hard sphere not actually a hard sphere. Does that seem reasonable?
Yeah, or something to switch it over to the hard squares, you mean?
Yes.
There's one other thing that I could think of in terms of the argument structure, that the calculation works a little bit like nest while, and you could put a time in there where, this mass of things that starts going crazy with a bunch of collisions, and then the computation hangs. So you might want an extra parameter as a cutoff for the number of events that you're willing to calculate.
Fine. Well, that's a max. I'm sure we've got, what's that?
Max collisions.
Or max
okay.
events.
Do we have any existing max
reflected
option that could be reused for this?
Well, max iterations, perhaps, if you consider a collision being an iteration, but
I don't like that.
I would say max steps.
A little bit too tricksy.
I think it could be max collisions. That's fine.
Yeah.
Oh, as an option? Because
Yes.
in the nest while, it is a full argument.
I know, but that's a very different kind of thing.
No, that's...
I do also think that it might be worth supporting an up to 10 or something like that for the time. Does that make any sense?
Yeah. It would be nice.
Why up to?
Yeah, why up to?
Because if it blows
we
up,
might not reach it.
Yeah.
It goes in the corner and makes exponentially small times increments before the next.
Yeah, but that's always implied. Like ND solve, we don't. I mean, up to is really an integer thing, and this is a slippery slope.
Fine.
And ND solve, for example, we integrate as far as we can, and then we
give a message.
It blows up. And it also shows in the result how far you integrated. I don't
precisely
know. Yeah.
And presumably
that might make sense here.
The simulation data should show that it. I mean, that's one of the things here is the simulation time, right? So it would.
And it would be nice to have periodic boundary conditions, even if the equations of motions aren't physically realized in flat space.
I'm sorry. So what were you saying, Michael?
Instead of reflecting, it would be nice to have wraparound boundary conditions.
Yes, it would be.
Both or a single one. So you can, in principle, simulate a long channel or something like this.
Yeah, right. But what happens for n-body simulation with periodic boundary conditions? Do we have a way of doing that? Because you have a region option, but that doesn't give you a way to make it periodic.
No, we don't have.
But this doesn't really make so much sense, because there the force field would discontinuously change because you go somewhere else. Yeah. But here, without forces, it still is a smooth continuation of the path on a topological torus.
Why can't you have? Am I being silly? Why can't you have forces on a torus?
No. You can, but then kind of you wrap around at the wrong moment. The distances suddenly change if you go to the left side from the right side.
I see.
Yeah.
I see.
Then you must really embed it topologically and metrically on a torus from the beginning.
Right. Okay. So how will we do that in this case? We'd have a region arrow. Well, how would we specify the periodic region then? It's got to be rectangular, doesn't it?
Yes.
Yeah.
I was thinking something like up, down, left, right, and reflecting, periodic, absorbing.
All right. We have to, but so this is similar to our PDE boundary conditions in some sense. Don't we have periodic boundary conditions for PDEs?
We have the symbol, we don't have a proper implementation.
Oh, can't we reuse that symbol at least for this?
We'd have to talk to Oliver because the whole
not really, because it requires a mapping from one parameterized of the boundary to another parameterization on another boundary.
All right. So anyway, more discussion about how to specify periodic boundary conditions, but clearly it's a useful thing here.
Yeah.
And do we want to talk about it more right now? I think it needs to be dug into in more detail. And you're suggesting that we have absorbing, reflecting periodic boundary conditions.
That would be the obvious one that come to mind for classical mechanics.
Okay, what is this MCMC method from Etienne?
Those are, I think that's a non-deterministic solver.
Right. Okay. What did Etienne in fact do here? This was Etienne's prehistory. What is this doing? And this is trying to determine configurations of hard spheres. Is that true? Huh. Okay. What is the story of our implementation, or what we should do with MCMC methods? Michael, you've been talking about this repeatedly.
Because it was the number one choice for people in COVID times to model COVID propagation. This case is now a little bit over.
Yeah, when I saw it, it was used for cosmological parameter extraction.
How does it, I mean, is it not relevant for other purposes?
I'm just not sure what general stuff you would have.
Yeah.
I mean, in general, I think most MCMC stuff, it's basically, it's a fancy random walk. I mean, it's not even a fancy random walk a lot of the time.
Well,
so you're saying there's no particular wrapper function that will be useful for it?
No, not that I can immediately think of.
I think it would be filed under probability and statistics, because my recollection of some of the stuff was that you're trying to recreate a posterior distribution or something like that.
Right. Yeah, like most of the uses that I've run into have been, you have some extremely complicated distribution and you're trying to sample from it, quote unquote, uniformly.
Maybe we already do this. Maybe this is what we already do for.
Well, no, it's stuff like, this one is a bit too hard, I think, even for MCMC, but it would be something like you want to sample uniformly from the set of all possible chess games, right? That would be something you'd use. I think that one is a bit too hard, maybe, but that's the kind of idea.
What does it even mean? What does that even mean?
Well, it would be if you have a set of all possible chess games, such a set exists, pick one uniformly at random.
I see what you're saying. Where each one is weighted, where a game is weighted, every possible beginning to end game is equally weighted.
Right. I'll give you an example of a concrete one, right, where people use MCMC for this. So if you have, say, a big network, and I say, partition this network into 10 pieces that are connected, 10 connected components, and give me, there are many different ways of doing that. I want you to uniformly sample some random partition of the network into 10 components.
Mm-hmm.
So people use MCMC for that. And basically the way it works is that you pick some arbitrary partition into 10 components, and then you do a random walk where you sort of change your partition little by little And you can show that in the infinite limit, if you do this random walk forever, the stationary distribution is uniform and you're uniformly sampling.
Right. Fair enough. So,
Well,
I mean,
what was the thing about the likelihood function?
Where?
With the Monte Carlo Markov chain.
Which thing?
Well, isn't the input part of the input specification a likelihood function?
I'm not sure. I think the main thing that you have to do to do MCMC. So first of all, when you're doing the random walk, you generally have to weight the in order for you have to weight the different sort of edges depending on the degree, the in degree of the different vertices, if that makes sense. So it's a biased random walk depending on how often you expect to, encounter different neighboring vertices.
Is that the likelihood function?
I'm not sure. I'm not sure.
Okay, but all right. So the question there is there any packaging of this MCMC thing? Well, I mean, this is very similar to what we were talking about before with, for example, this, you're saying, give me a random, for example, a list with all kinds of complicated characteristics. There are no pair of identical elements together, and there's a triple at this distance, et cetera, et cetera, et cetera. And then you say, give me a random thing that satisfies these conditions.
Right, but there's no magic there. In order to do a sampling like that with MCMC, you have to come up with a random walk setup, and you have to prove 5 things.
Yeah, I
you have
understand.
to prove that it's connected and stuff like that.
Right, but I mean,
maybe
general, yeah.
Well, I was just going to say maybe one general thing, but I don't really know enough about this to say anything. I've heard. So one of the big issues with MCMC is the mixing times. So that is, you're doing this random walk in the infinite limit. You'll be uniform, but in practice, well, I think often a lot of uses, even if you run it for 1 billion years, you won't even be very uniform. But that's a different issue. But there's supposed to be. I think it's very hard usually to prove just a priori what the mixing times should be. And so I've heard that there are certain visualizations that people use to try and, as their thing is running, to try and guess how mixed it is. I don't know how any of these work. I don't know what they are, but I've heard that such things exist.
I can guess it's like making in random cellular automata, you make one, a change in one place and you see how that grows. I mean,
I think the problem is actually similar to one that genetic algorithms have, which is with the genetic algorithms have a fitness function. But if the fitness function or the likelihood function have local minima that are significantly deep, you might not be able to get out of it.
I mean, it's the same thing in all these different schemes. But the question that I have is there a useful packaging of a function which we don't necessarily know how to implement in many cases, but is just given a constraint, find a random example that satisfies this constraint?
That random instance.
It is random instance, but it's random instance which we've only done for very particular cases right now.
Well, but I think that there is not a general case.
No, I understand that, but I'm asking, we might be able to pile on some other things, like some things with graph properties and so on. I mean, I hadn't really thought about this as a pattern for what the heck is that one? Such as a biomolecular? What the heck is the biomolecular case?
Where you can have meta characters in your sequence.
Okay, but so this random instance thing is then becoming the carrier of many kinds of things that could be of this type.
Yeah, I mean, there's a more general, I think, design thing about. There are a couple of functions like random instance and delete object, maybe a couple others that have been these cross-domain functions.
Yes, but I think random instance, what I'm suggesting here is that we have a little bit of a think of how else, random instance will be increase its visibility if it goes into another 5 domains. And, we've got specific things like random word, random point, and so on. And we don't really have a good way to say, we don't have a way to describe. Basically, you've got to describe a set in some way, I guess. And this is a very,
It's more like you have an abstract or not fully determined thing.
Yes.
And a particular instance of it. I don't know that it's really like sampling from a distribution per se.
But it is sampling. Even this is sampling from a distribution.
Sure.
In a certain way.
You're
hopefully uniform
distribution,
It's sampling from the space of solutions, not from a distribution.
Well, just the same thing. It's just a distribution where the probability of it returning an integer is 0.
Right,
we don't know what the distribution is that this generates. There's like randomness in the initial conditions, and then it does some solving.
Right. We don't know. Right. We don't know for example, if the distribution is uniform, but right. The probability of returning integer is hopefully 0. But
also this thing is set up to try and make nice looking instances, not degenerate ones.
Right.
I think the point though is that random instance in principle, its one argument is, its main argument is a distribution spec.
Right. But my question is this.
No, sorry, Christopher, I think I don't disagree. It's not a distribution, it's a set of constraints and it wants to get one possible solution. I don't think a distribution is involved.
Okay, sort of, yeah. I think right. As it's set up right now, you're right. It's basically a set. And it's not saying anything about, all it's saying is it's going to sample from that set and not things that are outside of the set.
Exactly.
But it's not saying anything about the distribution within things of that set. But if we had a more general, if we wanted to make all the random functions together, which I don't think we really want to do, but if we were, that function would take a distribution. And I think these sets of constraints can be thought of as distributions as well. It's just they're not fully specific.
Well, look, find instance is another example of something. Find instance is much like random instance, isn't it? What's the difference between find instance and random instance? That's bad.
I would have guessed a priori that the difference is that random instance makes more promises about sampling, uniformly or something.
I think
but
so
we know
too.
that's not the case.
No, I think it is the case, at least for the examples that we have here on the documentation page.
But weren't we just talking about how the geometric scene case, it tries to pick beautiful examples and stuff like that.
But it's still a much larger space than, like if you run it 1,000 times, you get 950 different. If you run find instance 1,000 times, you get one.
Same instance thing. Yeah.
Okay, so find instance is deterministic where random instance is not. Like find instances is deterministic but perhaps unpredictable.
Yes.
This is non-deterministic and unpredictable.
You can do random instance comma in instead of table.
Yeah, well, who knows what the distribution of these things is, and even what it would mean. It's a
right.
I think we should think about what other things we could have random instances of. Because like this, for example, I don't really see why there isn't a way to ask for a random value of x that satisfies this. Right? That is a well-defined thing. There's it's a uniform distribution, let's say, over this region. And that we presumably do have a way to ask for that. It just isn't packaged as given a constraint and random instance. Okay, let's put this for another time. Let's try and think about what random instances might be, what other things might be subject to random instance. All right, let's take a quick look at some of these other items here if we're ready to go on.
Okay. This is something that we've suggested off the cuff a couple of times, which is that much like geoposition of an entity should give a geoposition, that DateObject.
I agree. I think it should.
So the main hitch here is that there are a lot of possible date properties. In some cases, it's straightforward. Date is fine for a nuclear explosion or for a historical event. But for things like movies, it's probably a release date. For things like a dinosaur, maybe it's discovery date. For a building,
never discovery date.
Yeah. For building, it's probably construction end date. But for a lot of other cases, maybe a date interval makes more sense. For a person, date object, maybe birth date. There's a lot of ambiguity in terms of what we would do in a lot of domains. And I think we either.
Okay, let's think about that for a second. Okay, so there are dates that have a. Is Jose with us today?
He's not here today. He's going to be back next week for it.
Okay. Okay. All right. There are things that have definite. By the way, I assume that date object of an astro position will extract the correct thing.
Yeah, much like date object of a geo position will extract the date if that information is embedded.
All right. So the question here is, okay, what are some categories? I mean, look, clearly a date object of like a battle or something where we have, well, okay, what about a war that had a date interval? In other words, can date object supposedly returns a single date object? Go ahead.
Right. I think it would be very confusing if a date object, date object of entity returned a date interval.
Yeah, I don't think it can return a date interval without things going awry. You arguably could do what date object of a date interval does, which is give you the first moment in the interval, but that's going to be a little confusing.
Yeah. I mean, the other thing is just, I mean, maybe that would be the consistent thing to do if, well, okay, so I'm thinking of like, for example, I think there are some cases maybe in like military conflict data or stuff like that, where there are some entities that have a date and other, there's like a property where sometimes it's a date, sometimes it's a date interval, right? So you could never really return, I think there are cases like that. And if there were, you could never really return that unless you had some convention like what you just said of, maybe you pick if it happens to be at an interval, you pick the start or something.
Okay, let's look at these, which ones we think are realistic, okay? What is debate?
Probably like political debate.
Why the hell do we have such a thing?
That might be a dev mode one. I ran this internally. So
okay, all right.
So like holidays on there, and that's not an exposed.
Okay, board game, release date is okay, I think. Dinosaur, absolutely not discovery date.
Yeah.
If there is a date, it would be first appearance of the dinosaur. We'll be off by 100 million years or something.
Yeah, it'd be a very coarse granularity to begin with. I think in general, discovery date doesn't make a ton of sense.
No,
like
I think
if you want the discovery date, you look for it. Formulation date, maybe.
Yeah, maybe.
Yeah, I'm a little worried that, right. It's just that
I think
it just seems like the whole construction is a little bit suspect in the sense of like, is it really good code to write date object of a person or something, even if you happen to know that, oh, this would be the birth date?
I think there are certain domains where it's intuitive, like we were saying, a historical event or something like that. If there's a finite date.
Let's just look through this list, okay? Dog breed, no. Element, no. Exoplanet, no. Famous algorithm, I think probably no. Gem, no. I don't know. Maybe on this one. Financial.
That's the same as the algorithm, though. I don't know. Are games invented or discovered or something? Especially math games.
Those seem iffy. Financial is a no, I think. I can't imagine why that will be useful. Just get confused.
Yeah.
Genome assembly. That one I think is a yes. Holiday, presumably.
What does that mean? Genome assembly?
Oh, assembly 37 of the human genome, for example.
In a certain assembly was released.
Lunar eclipse, I would think, yes. Meteor shower, sure. Mineral.
Although actually, sorry, already for genome assembly though. This is the sort of thing where I think it could sort of get you into trouble, where you just say date object of genome assembly, but you don't realize it's the release date and not, I don't know, when the sample was collected or something.
Well, I think for that particular case, it's a reasonable thing because that is the only date. There is no sample collection thing, but these
Well, that
are
we have.
canonical.
Yeah. So this particular set here is just instances of domains where we only have one date property. There's a whole section below that where there's multiple dates.
Okay, but let's look at some of these of which ones. I mean, things like mountains, no way.
Mm-hmm.
Right? No way.
Yeah.
Music album release, sure, why not?
Mm-hmm. Same with
Movie, I would say the same thing. I mean, nuclear explosion, absolutely. Planet, absolutely not.
Right. I think the case is, imagine you saw a piece of code where it said, date object of, I don't know, pick your favorite movie, Star Wars. And, would that be readable? I think that's probably a yes.
Yeah. Shipwreck is a yes. TLD is probably a no, even though that is a fairly well-defined thing. I just don't think that's okay. Let's
right. The date object of google.com does not, it's not
make
obvious
a lot
what
of
that
sense.
means.
Right. I mean, artwork, sure. Completion date, I would say, sure.
Wait, what's the start date? Oh, it's his start versus completion.
Michelangelo has.
Well, no, but you can't just say completion so willy-nilly because we were just talking about how the convention for date intervals is you take the first.
I think by the time only the left foot of the statue is done, it is not that is not the date of the artwork. And I would
But
say
see, this is the sort of thing though where it's I'm afraid that it's just you're gonna have a piece of code where it's date object of David, and it's going to be like totally unclear what that means.
I mean, the
and
convention in our history is
things.
certainly to use the completion date. You might have an interval in some cases, but
I think the point is that it's the El Cheapo version. I mean, if you want to get it right, you're going to go in and look which date is it. But it's just I've got these things and I just want to do some rough.
Yeah,
I mean, it's a courtesy.
I was thinking it's analogous to geoposition of France. You're going to get an answer. It may not be, maybe it's a representative location that is a rough approximation of it.
Right. I think that there are things that have a moment in time, like an artwork has a plausible moment in time.
Mm-hmm.
Even a bridge, I'm skeptical about. I mean, anything that's out there for a long time in operation, and it's not something where I don't know. I mean,
do we have a standard way, by the way, for like if you use geographics, you can give it a bunch of entities, or like geolist plot. Do we have a similar thing with timeline plot where we've already decided on some way of resolving entities?
Yep.
Well, that's what this is about. And that's what, I mean, honestly, in resolving entities here, for example, for people, we really want the date interval, which I don't think we have right now. Do we?
No, there's not a single date interval property. There's a burst.
No, if I say timeline plot of, Alan Turing, I don't know. That is pathetic. That's pathetic. Right? That should work. And it should work with date intervals. And yes, that is going to require us to have a canonical meaning, just like geoposition of France has a canonical meaning for what that is. I think here, the date interval, I mean, like country, for example, presumably that is an independent state. I don't know. Maybe that one is hard to do, but this should do something.
Shouldn't the United States, for example, be when the Constitution was ratified, not when independence was won?
Okay, what's this? This
is an example with historical events that does an interval. It does start and end date.
Well, great. So it should do that with people as well.
Yeah.
So we've already got a pattern for this. But we just need to figure out what some of these ones are. Look, things like, a manned space mission. We can surely manage that. The date interval for that.
Right. Maybe that's a good baseline, is start with things that make sense on timeline plot. I'll sit down with Brett and Alan and just kind of itemize things.
Fine. I think there are two cases. There are things that make sense in timeline plot. I mean, there's also the question of whether if you give date interval of something, if you say date interval of a person, maybe it just returns the correct thing, the correct date interval. That seems convenient. And some other things.
Country, historical period, those all have a definite start and end.
Right. But also the there are things that have a moment in time character to them, which can perfectly well return something for date object. I think there are things where people will kind of know this is a courtesy, basically, is what is really the thing here. If you want it more precisely, you've got to specify what property it is. What on earth is this?
That's a bug that's a domain that isn't exposed yet, but there's a format.
All right, so I think we've got a plan here. So date object for the things that have a single date, date object is good. For the things that have a begin and end, date interval is good, and timeline plot should try both of them, so to speak. Should appropriately surface whichever one is the right one.
Okay.
And don't be too creative.
Yeah, it should be intuitive what it's going to do. If there's ambiguity, then it probably.
Right. I mean, dinosaur on a timeline plot.
Yeah.
We know what that is. That is not sometime in the 1800s, right?
Right.
It's. I want to see whether the Stegosaurus was alive at the same time as the iguanodon or something. And I'm probably out of date with my dinosaur names. Those probably discontinued by now. I think the iguanodon was discontinued. Okay. All right. Okay. So we have a plan for this. Yes. Everybody happy with these?
I think so.
I don't think we're going to. We're probably not going to get far with this, but we could just look at it again. Directed zero. Do we have Rob here? Because Rob will be relevant to that.
I think Rob already left.
Well, he's relevant to that. If we have
Okay.
Michael might be relevant to that too. I don't know whether Michael has something.
Michael's still here.
Yep. Directed zero would be nice to have.
Well, then let's have a discussion about it. I don't know enough about it. That's more complicated. Clean up XML handling in trees. Isn't that something that's underway now with Ian?
Yes.
Okay. General algebra. Whatever that means. I mean, that's sort of universal algebra in some sense. Being able to do universal algebra, having a convention for universal algebra, because universal algebra on its own does nothing. Michael, do you have any comments on that?
I don't know enough what exactly meant here.
It just means.
I mean, it seems not even algebra, honestly, from what I read. It's even a pre-version of algebra.
Yes, it's
I mean, algebra has already certain rules encoded. Otherwise, it's not an algebra.
I think what this is about is arbitrary binary and unary operators.
Like associativity would be something that's required for an algebra.
Right. I mean, it's
not
like
universal
a ring
algebra
or something.
But then you would no longer call it an algebra. Then you would preface.
I know, but that's what people called universal algebra was just a thing that has operators and relations. And you don't specify the relations at the beginning. You just have an operator, like a binary operator.
Right. I mean, it seems like it might be nice. I mean, it could be nice to have something where you'd have like ring plus ring times field plus field times, etc. And it basically just assumes that, the variables on either side are elements of a ring, field, whatever.
Arguably, this is what we have with the axiomatic theory of ring and field and so on.
Yeah, that is probably the nicer way to do it.
This is part of the ongoing discussion about formal variables and what do we mean by a variable, what do we mean by an operator, because there's really formal operators as well as formal variables. Whatever happened to our formal variables discussion? Anybody know? Can we look at that again? We were having this discussion about the meaning of variables like a year ago.
Yeah, I'll bring that up with Itai.
Okay.
So have a comment. Like something that people do recommend is having a couple built-in rules for non-commutative multiply.
Mm-hmm. Well, we can look at that. That's part of the same story. All right. Let's do formal variables, universal algebra, non-commutative multiply. That's a topic. Okay, last item here. Softmax. Is there an easy story here?
I think the main easy story was that there's a pretty closely related operation that we do have a function repo implementation of.
But softmax seems to be a thing that is heard from. What's happening here? Why
sorry, is this just to be a function for running softmax?
Yeah.
Does the softmax layer not basically do that?
What is the lay? Oh.
Wait, I'm confused by that because, I mean, right. I don't see how this is just different from softmax layer also.
Yeah, but we also tend to just have functions that work on lists. I mean, layers usually have a whole.
No, but they do work on lists. If you just do, or kind of, I mean, if you just do softmax layer open close of list 1, 2, 3. Pretty much all the neural network functions you can apply a layer to a list and it will work.
Okay, but is this function interesting enough that it should just be available as, the function softmax of a list?
I mean, I'm not sure when you would ever do it outside of a neural network.
What is the definition of it?
I don't remember, but it's some exponential thing.
Yeah, I thought it was some well-defined thing like a logistic formula.
Yeah, it is. It's a very standard thing. But I mean, see, we also have, cross entropy loss layer. Should we have a function called cross entropy loss? Oh, there it is, by the way. It's normalized of exp comma total. Oh, sorry, when softmax layer of -1. Oh, but that's the default. Yeah, okay. So
okay. What does the total do in the normalized there?
We just need the probabilities to sum to 1. Oh, the total is that the second argument is what it divides by in order to normalize them. So the default is, I think, norm. So that the norm is 1. But if you say total, then the total will be 1.
I see. I don't know. I mean, is this function something that is useful in general computation, or is it only useful as a particular hack in neural nets?
I've never seen it used outside of a neural net.
Fine. Anybody else got comments on this?
I agree with Christopher.
Okay. All right, we can forget that for now. All right. Anything else here? Okay. Until the next time. Thanks a lot. See you all soon.
Thanks, everyone.
Bye.